in this topic we are going to show you the integral as a limit of sum. Now we have learned that integral a to b f of x dx. What does this mean? It means area bounded by the curve y equal to f of x, the line x equal to a, the line x equal to b. Whatever the area inside this is nothing but integral a to b f of x dx. Now we can find this area by using the summation and limit. That's what is known as integral as limit of sum. Now what we do is we will divide this area. I'm just enlarging it. This is a, this is b, which means this point is a comma 0, this point is b comma 0, which means this whole length is b minus a. It's divided into n strips like this. Each strip is of width h. So the value of h is b minus a upon n. So what we have done is we cut them into like this small strips with width h. The calculation of width h is b minus a divided by n. Then what else we can see? We can notice that the coordinate of all these points can be estimated. For example, the first point will have x coordinate will be a, the y coordinate will be this length which is obtained by substituting in the function y equal to f of x. If you replace x coordinate by a, this point will have the point a comma f of a. Next will be this width is h, so the x coordinate will be a plus h and corresponding y coordinate will be f of a plus h, and goes on like that, and that we can get all the points. Now what we do is we take rth strip, we find out the area of this using area of a rectangle's formula. So the width is h and this height will be f of a plus rh, and the width over here is h. So area will be h into f of a plus rh. For example, when r is 1, you will get this as the area. When r is 2, you will get this as the area. When r is 3, you will get this as the area. So we will be finding area of all these rectangles. So if you add them up, r is equal to 1 to n. You can also write r is equal to 0 to n minus 1. This is also correct. In this case, you will be taking area in this manner. This is f of a plus h. This is f of a. R is 0 means f of a into h. Like this also you can take the area. So both the formulas are correct. R is equal to 1 to n is also correct. R is equal to 0 to n minus 1 is also correct. Let me deal only with one of them. So we are taking area in this manner. Then what is the problem that you notice is that they both are not equal. Why they are not equal? Because there is some area above the curve. To reduce or to make this extra area minimum, you can just see I am enlarging this part. It will be like this, something like this. And you have taken this much area. Suppose we had two divisions. Instead of having one division, if you divide them into two divisions, you can see that the extra area will still reduce. If you have 4 division, you can see extra area will still reduce because now the rectangle's area will be there. So you imagine 1 division, so much area. 4 division, so much area is reduced. So what you notice is, if the number of divisions are very large, this extra area will go away. Therefore, I can say limit n tends to infinity. This is nothing but integral a to b f of x dx. So this is a formula for integral as a limit of sum. So you can write this formula in two ways. One is this way, another is this way. This is also the correct formula. Both are same thing. Only thing, one is starting from the f of a plus h, f of a plus 2h, etc. Other is starting from f of, so it will end with f of a plus n minus 1h. Otherwise, start from f of a plus h and end with f of a plus n and n plus h. F of a plus nh. So both the formulas are same. One is 0 to n minus 1. One is 1 to n. Both the ways you can write it. Now, what we do in this integral as a limit of sum, how we apply it to get the limit evaluation, how to evaluate limit using this formula. So let me write this formula once again. So the formula for integral as a limit of sum is limit n tends to infinity h into sigma r is equal to 1 to n f plus rh, f of a plus rh, where h is b minus a upon n. Now what you do is, you put a as 0 and b as 1, then h will become 1 by n. So the integral 0 to 1 f of x dx will be limit n tends to infinity. In place of h you write 1 by n into sigma r is equal to 1 to n f of a is 0, r is r only, h is 1 by n, so it become r by n. So this is a formula that we will be applying to calculate integral as a limit of sum. So this can be written in two ways. One in this way. It can also be written in this manner. 1 by n sigma r is equal to 0 to n minus 1 f of r by n. Both are correct. So this way also you can write, this way also you can write. Both the ways you will get the same formula. Apply this formula to calculate this limit. This is a simple problem. You can do by other methods also. But at present, let me teach you by this formula so that you understand the technique. Step number 1 is to use the step 1. Find rth term of the series. How do you find the rth term? You can imagine this to be 1 square upon n cube, 2 square upon n cube, 3 square upon n cube, and goes on like that. Which means first term is 1 square upon n cube, second term is 2 square upon n cube. So naturally the rth term will be r square upon n cube. Denominator is n cube is constant. What varies is numerator 1, 2, 3, first with 1, second with 2, third with a 3. So rth term will be r. Then step number 2 is apply sigma notation. Apply the sigma notation. So when you apply the sigma notation, I can write 1 square plus 2 square plus 3 square plus etc. n square upon n cube as sigma r is equal to 1 to n r square upon n cube. For even summation of series also we did this. Whenever we want to find the rth term, each term you find and then put summation. So now I can write this as, this particular question as limit. So step number 3, my aim is to convert this into this format. So I will write first of all, limit n tends to infinity, sigma r is equal to 1 to n r square upon n cube. R square upon n cube. Now look at the formula. I need a 1 by n outside. So limit n tends to infinity. 1 by n got to be removed outside. R by n the whole square. So we have got the function f of r by n. F of r by n is r by n the whole square. Now we'll compare both. After finding the rth term, summation notation, then comparing. Now when I compare this both, let's have a comparison here. I'm writing one below here it. Limit n tends to infinity, 1 by n, sigma r is equal to 1 to n, r by n the whole square. So what does that mean? It means f of r by n is r by n the whole square, which means f of x is x square. So the function is x square. So the function is x square. So which means this is nothing but integral 0 to 1 x square dx. So if you integrate x cube by 3, 0 to 1, hence answer is 1 by 3. So the limit of this function is 1 by 3. So what I have noticed, limit n tends to infinity, 1 square plus 2 square plus up till n square upon n cube can be written in this format, compared with the formula, found out what is the function. Function, we noticed that this part is equal to this part. So we got that. R by n is replaced by x. We got the function. We replace the function here, integrated to get the answer. So this technique we are going to use. Now I'll do it much faster than this in the next problem. This problem. First, what is our first step? Find the rth term. First term, what is the variation? Numerator is all 1. Denominator all start with n. 2n can be assumed to be n plus n. So I can say the rth term will be 1 upon n plus. So much is fixed. There is no change. First term 1, second term 2, third term 3, etc. It was 2n, so n plus n. First term 1, second term 2, third term 3, nth term is n. So r here. So if you put r as 1, I get this. R as 2, I get this. R as 3, I get etc. Then I put the summation. R is equal to 1 to n. This is the and limit n tends to infinity. So I converted the question into summation notation. Now I recap the formula. What is my formula? Formula is limit n tends to infinity 1 by n f of r by n is equal to integral 0 to 1 f of x dx. This is our formula. So the formula requires a 1 by n. So since I don't have a 1 by n here, I'll divide and multiply. 1 by n. This is equal to this. This is equal to this. I put a 1 by n. Sigma r is equal to 1 to n upon n plus r. Now after this, I have to convert this a function in r by n. What do you mean by function in r by n? Every term that is present in that function should be r upon n. So what I'll do, I'll divide numerator and denominator by n. So if I divide numerator and denominator by n, this becomes n divided by n is 1, n divided by n is 1, r by n. Now compare this with the formula. 1 by n is present, and I didn't write sigma here. Sigma, I'll rewrite the formula. Okay, I'll rewrite the formula here. Limit n tends to infinity, 1 by n, sigma r is equal to 1 to n, f of r by n. This is our formula. Now compare and that is equal to integral 0 to 1 f of x dx. So what is our r by n? Let's compare it. So we have seen f of r by n is 1 upon 1 plus r by n. So f of x will be 1 upon 1 plus x. So what I can write this as? This is nothing but integral 0 to 1. This is f of r by n, but we need to write f of x. So f of x is 1 upon 1 plus x dx. We know its integral is log of 1 plus x from 0 to 1. Now apply the limit. Log 2 minus log 1. Log 1 is 0, hence answer is log 2. So that becomes your answer. So I can say the limit of this function is log 2. Let's practice more. Okay. Let's look at this one. First of all, we have to generalize. 16n square is present, 16n square is present, 16n square is not present. Here we can make it 16n square, so modify it. Limit n tends to infinity. 1 upon root is required. 16n square minus 0 I can write. Plus 1 upon root 16n square minus 1. Plus 1 upon root 16n square minus 2 square. And last one, I will add and subtract n square. 16n square and n square plus 2n minus 1. This can be written as n minus 1 the whole square. N minus 1 the whole square. So I made everything in the same format. So my rth term will be 1 upon root of 16n square minus r square. So I will be writing r is from 0 to n minus 1. Anyhow, there are n terms here. So it does not matter whether you start from 1 to n or 0 to n minus 1 because n is tending to infinity. So we can continue the formula in the same manner. Instead of 1 to n, we write 0 to n minus 1. It doesn't make any difference. Now I need an n in the formula. Again, recap the formula that we have learned. Formula is limit n tends to infinity 1 by n sigma r is equal to 1 to n f of r by n. This is our formula. So we need 1 by n. So first we will make a 1 by n come into it by dividing and multiplying. So 1 by n has come. Now you have to make it a function in r by n. There should be only r by n in it. So I will divide numerator and denominator by n. So sigma r is equal to 1 to n. 1 upon root of this n. I can also think instead of this way. This is also fine. So directly I'll get in denominator. Now take the n inside. So s is n square upon n square minus r by n the whole square. So I can write this as limit n tends to infinity 1 by n sigma r is equal to 0 to n minus 1 1 upon root 16 minus r by n the whole square. Now compare this both and tell me what is f of r by n. So f of r by n is 1 upon root 16 minus r by n the whole square. So what is f of x? 1 by root 16 minus x square. So what will be the answer for this? So answer for this will be integral 0 to 1 upon root 16 minus x square dx. And you know that this is nothing but sine inverse x by 4. From where to where? X by 4 from 0 to 1. So if I replace here, answer became sine inverse of 1 by 4. And that is my answer for it. Sine inverse of 1 by 4. Let's see a small change in this problem compared to what we learned just before. First of all, we'll write this as 1 up limit n tends to infinity 1 upon n plus 1 plus 1 upon n plus 2 goes on like that. 1 upon what is constant here? N is fixed. So n plus phi n. That means your r starts from 1, n at phi n. So I can write limit n tends to infinity sigma r is equal to 1 to 5n 1 upon n plus r. As usual, I have to see that the limit is from 1 to n, single number n, not 5n. So what I'll do is, I will first of all bring a 1 by n. 1 by n. Or I'll do one thing. Before I start that, I will put phi n as a single number m. Then n will become m by phi. Also, as n tends to infinity, m also will tend to infinity. So I can change this as limit m tending to infinity sigma r is equal to 1 to m 1 upon m by phi plus r. I can write this way. Now I will proceed. So my first problem is solved. Instead of n, I'll be having m here. That's the difference. So limit m tends to infinity 1 by m into sigma r is equal to 1 to m 1 upon m by phi plus r divided by m. That is, I divided and multiplied with m, which is equal to limit m tends to infinity 1 by m sigma r is equal to 1 to m 1 upon 1 by phi plus r by m. So instead of m by phi, I'll have 1 by phi. So now this is exactly into our formula. Let's recap our formula. Limit n tends to infinity. Limit n tends to infinity 1 by n sigma r is equal to 1 to n f of r by n. So tell me what is f of r by n here? F of r by n is this. So I can say f of r by n f of r by m is 1 upon 1 by phi plus r by m. So f of x will be 1 upon 1 by phi plus x. So what will be your answer? Your answer will be integral 0 to 1, 1 upon 1 by 5 plus x dx, which is log of 1 by 5 plus x from 0 to 1. So that became log of 1 by 5 plus 1 minus log of 1 by 5, which will become log of 6 by 5 upon 1 by 5, which will become log 6. So your answer became log 6. So just see the change here. Your 5n, you need a single letter. So instead of n, I have to make it converted into m. So if you have 5n, then convert it into a single letter m by substitution method, change everything in terms of m and compare the formula accordingly and get your answer. So every time you have to identify the function. Once you identify the function 0 to 1, if you integrate, you get your answer. Similar to the previous to this problem. So this is limit n tends to infinity. So what is constant? Root 4n square is constant. So I can write here root of 4n square minus 0, 1 upon root of 4n square minus 1 plus dot 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 1 upon this. Also I need to make 4n square by adding an n square plus what will be here? N square plus 2n minus 1 will come here. So n minus 1 the whole square. So I can write this as limit n tends to infinity, sigma r is equal to 0 to n minus 1, 1 upon root of 4n square minus r square. Again as usual, divide and multiply with n. So limit n tends to infinity, 1 by n, 0 to n minus 1, there are n terms. So you don't have to do anything with this. You keep it like that only, because it is 0 to n minus 1. 0 to n minus 1 is number of terms are n, so it does not matter. So I will write root of 4n square minus r square upon n. Again, my aim is to make it as a function of n. So you would have by now got the idea. I can write this r is 0 to n minus 1, 1 upon root of n square upon n square is 4, r by n the whole square. This is equal to integral 0 to 1. This is your function, 1 by root of 4 minus x square dx. R by n, if you replace by x, you will get the function. Now you can be much faster than what we did before. No need of comparison. You can just look at this and say your answer. And this is nothing but sine inverse of x by 2, sine 1 by root a square minus x square is sine inverse x by a. This formula I have applied. So limit is from 0 to 1, which is sine inverse of 1 by 2 minus sine inverse of 0. Sine inverse of 1 by 2 is 30 degrees. So answer is pi by 6. So this is how you can calculate this limit. This is a little tricky problem. What I'm going to do is, see, you can see here, okay, let's just expand it to understand. It is n factorial. So 1 into 2 into 3 into etc. n. And this n I'm dividing it by each. So I can write 1 by n. But I cannot apply any sigma over here. There is no sigma here. Everything is multiplication. So how will I convert this into summation? Very simple method. Take an e and log you put. Or you can do one more thing. Now, limit and log can be interchanged. So I write limit outside and log inside. So e raised to limit n tends to infinity. This can be written as log of, first of all, this 1 by n. 1 by n, the power comes in front. Log of 1 by n plus log of 2 by n plus dot 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 log of n by n. So this I can write as e raised to limit n tends to infinity 1 by n into sigma r is equal to 1 to n log of r by n. This much is your formula. So I can write e raised to integral 0 to 1 f of x. F of x is log x. So your answer is e to the power 0 to 1 log x dx. Now we will integrate 0 to 1 log x dx. You know how to integrate 0 to 1 log x into 1 dx. That is first function into integral of second minus derivative of, so you get x log x minus x. So I can write this as, okay, I'll put the limit 0 to 1. So log 1 is 0. So you will get 0 minus 1. When I put x as 1, log 1 becomes 0. When I put x as 0, this part will be fully 0. You will get only minus 1. So this answer will be e raised to minus 1. Hence your answer is 1 by e. This would be your answer. This is quite a tricky problem. You should understand when multiplication comes, we cannot apply this formula. In such a situation, you have to bring log and take the answer. So summation can be made, multiplication can be converted to summation only by taking log. So take e raised to log. I hope you understood the interchanging of limit. Over a plus sign, limit can be always interchanged. So log inside log, instead of applying the limit outside the log, you can take the log inside and both ways. The question which you asked me was this particular problem. Now this is a very simple problem that you yourself can see. It's a direct problem. You have 1 by n square. Your formula requires only 1 by n. So 1 by n outside, sigma r is equal to 1 to n, r by n into e raised to r by n. So what is the function here? X e raised to x. So your answer is integral 0 to 1 x e raised to x dx. Now integrate by parts. First into, which is the first one? LIATE, e always last. So first into integral of second minus integral of derivative of first is e raised to x dx. So it is nothing but x e raised to x minus e raised to x from 0 to 1. This is equal to when you put upper limit e, when you put upper limit e, when you put lower limit 0 minus e raised to 0, they both will get cancelled. So your answer is 1. So I put x as 1, so you got e, put x as 1, you got e, put x as 0, you got 0, put x as 0 here, you got 1. So your final answer is, this both got cancelled, minus of minus plus 1 becomes your answer.